everyone together, welcome on Vishnu, who's going to be the next speaker. A round of applause and a big yes. There we go, there we go. That's the energy we want. Let's go.
Hello guys, how are you all doing? Good. How's React India? Awesome. Cool. So I know this is a post-lunch session, and don't worry, I have enough caffeine packed up for you too. Cool. I would like to kick this off with a real story. Back when I was working for a startup, we were tasked to build a virtual try-on tool for makeup. So that time was like we had to demo it to one of our clients. And my CEO comes up and says, hey, for the demo, we need to get this real quick, and we need to make sure it is super private, it is super secure, it is super fast, and make sure we are not burning AWS credits for this. And I thought okay, how can we do this? You want me to run landmark detection and rendering in real time without a server? I was like, okay, let's try to figure it out. Just like any engineer out there, we had two obvious solutions. Either we had to write a service in TensorFlow or PyTorch, or we had to go with third-party APIs or a cloud service. If you go for PyTorch or TensorFlow backend, I obviously had a trade-off. Obviously, because we can't just, at that time, we were not in a position to burn money just for a major demo. So yeah, about the third-party APIs, who wants their face data to be sent off just to see how lipstick looks on their face? Nobody, right? So yeah, that's when I figured out something amazing in browser ML. And yeah, it worked really way better. This demo was smoother than we expected. And that's when I discovered this is something not only for the one demo. This could completely change the way we think about UIs and how we personalize it. And yeah, this is what my reaction was. All right. So quickly about me, I'm Vishnu. I'm a product engineer at CareStack. I work with a front-end team that builds VoiceStack. So VoiceStack is basically an AI phone system that is tailored for healthcare. We believe healthcare talks about the most everywhere, except the place where the patient talks the most, the phone. And yeah, we are doing that. Cool. When I'm not coding, I'm allowed to explore a lot of places. I love to travel a lot, just like I'm here at Goa now. And I write about blogs, text, articles, and all. I love to mentor my juniors. And yeah, I enjoy volunteering to tech conferences like this. Yeah, that's OK. This is pretty much what we're going to cover today. We'll start from why hyperpersonalization matters. We'll go from how to achieve that, how we can bring machine learning magic to React. And we'll wind it off with some performance optimization statics and some limitations. Shall we kick off? Cool. OK, let's be honest. Nowadays, users no more want generic UIs. They want all new Netflix-level personalized websites in their day-to-day sites. They're not the same anymore. And also, we've come through a long way. We started with static UIs. Then we built responsive UIs. Then came personalized UIs. And now, we are entering into a new era, adaptive UIs. Or we can call that hyper-personalization. Cool. What does the word hyper-personalization even mean? Well, hyper-personalization means it's a mix of real-time data-driven components getting adapted to the layout based on how the user reacts in real time, how the user works, the real data, and the context. So this is what hyper-personalization stands for. So there are various ways with which we can achieve hyper-personalization. The first one, the obvious thing, rule-based personalization. This is something everyone would have done. We can show the dashboards or something based on the rule, based on feature toggles. Everyone would have done that. But the thing is, we cannot call that adaptive UI. That's not adaptive at all. It's just simple, easy to implement. And there is server-side ML. What is server-side ML? And that's how most of the websites, most of the web apps, ML-based apps run today on the internet. They are using servers. Servers are great until the privacy and the trade-offs comes in. OK, what can we do for that? There comes in browser ML. we can run literally a machine learning model inside the browser. The UI can adapt instantly based on how the user reacts. We can create predictive search, adaptive layouts. We can theme the user's experience based on the mood. If you are on a separate website, the UI won't be same for you. It's going to be different to you, different to be you. So this is something cool that we can do. Before that, we get this question. Why run a ML model in a browser? Is that going to be so heavy? How are you going to do that? Like, is it going to crash my browser, crash my phone? Yeah, that's a good question. Well, there are a lot of benefits for that. No API calls. There is no server round trips. We have the solutions like the things feature working in less than 10 milliseconds. Just think, like everything adapting just like Thanos Snap. So it's so cool. And your data never leaves the browser. It always stays in, and it is super private. It can be used in places where the privacy is respected the most. And the best part, your feature works even without the internet. If someone lost the internet, if there is some issues with the connections, no worries, the feature still works. That's so cool. And obviously, it's going to cut down the cost. So I would like to ask a question. Anyone has actually tried compiling something in WebAssembly before this? You can see a few hands over there. Cool. For the rest of you, WebAssembly, you can think of it like you can run literally any language inside the browser. You can write anything, like in a low level, it runs in a low level code, like low level byte ordering. So it is so fast, it's super fast. Let's see the demo so that you'll understand better. So how this works? This works by WebAssembly. Most of the in-browser ML libraries today, that is built like using this WebAssembly, or we can simply call it WASM. So what WASM does? WASM takes all the input. It basically runs and gets the output in byte level, so that it is not like taking so much time. It's going to, we can think of it like React plus C level speed in a browser. So cool, right? Yeah. You can see the benchmark of how WASM performs compared to a native speed. Like, it is so near. It's like performing really good. So this is why WASM is being used for these kind of ML computations. And this is a boon for us. OK, now we have seen what is personalization, like what these things do, how these things do. Now let's see how we can bring this magic to React, our actual topic of concern. Cool. First, we have to start with choosing the right library. There are lots of libraries. These are the most common things. There is TensorFlow.js. TensorFlow, everyone has, everyone knows TensorFlow, right? This is TensorFlow.js. TensorFlow right in the browser. So TensorFlow is best for when you have complex ML features, or even better, you have your own ML models that you have to bring in the browser. You can use this one. But it has a trade-off. The bundle size is too high. It's so complex. But the best thing is it has a very good community, so that we get help everywhere. Then there is Onyx.js. Onyx.js suits best when we have cross-platform compatibility. We have lots of ML models that has to run differently in different browsers. Then Onyx.js works. And this is a very thing that many people don't use. So it has less community presence, and it's that's one of the things. But it still does great. ML5.js. It's a library that is beginner-friendly, which is great for demos, MVPs, prototypes, and all, but doesn't work that good for production when we scale. And yeah, this is how a machine learning model runs in the browser. What do we do first? First, we load the model. Then we pre-process the input. What do I mean by that? We have to make the data ready. We have to abstract the data. We have to get the things ready for the browser. And we are feeding that to the machine learning model. We are running the inference. This is where the magic happens. And it gives us the data back. And then we post-process it. We do some styling, some tinkering stuffs, and we show that in the UI. So this is how a machine learning model runs in the browser. We'll see how we can integrate it in step by step. Cool. How many of you directly used a ML model in the browser? Wow. Few hands. How many of you have used API or any cloud services for that? Most of you. OK, now let's see how to bring that in React. Cool. This is how we do. First, we start importing some libraries. I think I can better show it with a demo. We can start, like we're starting with importing some libraries and bird tokenizer. What is bird tokenizer? Well, bird tokenizer is basically, oh, wow, TypeScript error. Oh, cool. If at some point anyone says nothing is going to stay forever, just say TypeScript error is going to stay. Cool. So bird tokenizer is nothing but it is a model that Google developed that we can use to predict like a lot of things, and we can get some stuffs out of the text. It's kind of like text predator. And I'm using a small modification of that to predict like how the user is behaving via the text they are giving. This is what the demo is going to do. Cool. This is what bird tokenizer does. Yep. Then we are initializing the model. We are running the model, like we are loading the model in every component mount. Then we pre-process the input data. We initialize the tokenizer that I told you earlier. And then we encode it. Why do we encode it? Because machine learning models don't understand text. They understand numbers. So first, we encode it. Then we have to convert it into tensors in the language where these ML models understand. So we are doing that. And we are getting the input. Like we are using the encode input function that we wrote just now. And from the results, we are getting something called as logits. What is logits? Logits is basically like a confidence score that this thing gives us that we can use to map with the emotions, the data, whatever we want. Yeah, obviously. Next, we're setting the predictions. And this is our input box. We are showing the prediction in the UI. Trust me, the UI is going to be looking much better. OK, let's see how that looks. I just want to walk you through the code a little bit before I show you the code. OK, is it visible? Like, should I zoom in a little bit? Zoom. Fine? All right? OK. There are a few hooks over here. What this does, this is taking the content recommendation. This is the thing that we discussed over there. Like, what is the best emotion? It's going to take that. We are setting the mood context based on some data. And yeah, we are setting some themes. We have some components over here. We have the main component. We're passing the props. And yeah, we have this recommendation item. Though the recommendation item here is just static, we can scale them to be much dynamic in the future. It's just for this demo. Cool. This is what pretty much this demo does. Like, I think I'll go with the UI. But yeah, this is how it works. So I'm going to say I'm so excited about React India 2025. The mood has changed. Like it says, I'm in joy mode. OK. I'm going to say, I want to learn about AI advancements. Oh. It still doesn't do a great job because I trained this data with this Google's Go Emotion data set. This is a good data set, but still, AI doesn't work always. Don't worry, guys. Our job is safe. I'm going to say, I got a TypeScript error. And what? And it sucks. And it properly figured out. You're frustrated, you're alerted. And I hate my life. Okay. Now if you see in the network, I want to show this to you. Like, for every prediction that comes, there is no network calls being done. Even the reloads are faster. It's just the bird that is being initialized. Maybe what else emotion we have? We have a lot of emotion over here. Can you guys give me some example things that I can put over here? Give me something. Okay. The crowd has no energy. Has to be more energetic. I'm not balanced and calm. I'm so frustrated. Maybe I'll add a word. I'm so frustrated. Yeah, it says I'm in a sad mood. Okay, yeah, I'm in a sad mood. See, it even recommends some things like copy strategies for difficult times. Oh wow, this can work really great. Like when it is scaled in a really better level. Well, we can come back to this part. Cool. We saw how the performance worked. But like, the very next question that everyone would have got is, OK, let's answer this. What do you think that matters most while building a UI? Model's accuracy or load time? A? Who say A? Accuracy. Who say load time? What about the rest of the hands? Maybe both. Cool. OK. Yeah. I'm sure the first thought that everyone would have got in your mind that when I told about I'm going to load an ML model in the browser, that why would you do that? What will happen to the browser? Like, it will die. This is how our reaction would be. But yeah, it is not always great. But with the right optimization strategy, and if we apply some few tricks over there, we can get really better output from this. What we can do? Like, how many of you face this situation? Like, when we had some bug in our work, we think all about in the night, all about when we are in the bathroom, and we suddenly realize, I just missed a semicolon. OK. Yeah. This is how like, we used to think. Right. There are some model optimization technique and quantization. Compression, like, you can think of it like we are compressing a video. If you're compressing a 1 GB video to some 200 or 300, it's going to be a bit bad. But like, in case of machine learning, yeah, the accuracy is not going to fall mostly apart. But a super fast output, a wrong output, that is better than little bit late right output. Right. So yeah, these are some benchmarks that have been done. If we run a small CNN model, which is originally of 5 MB, and it is quantized, it can help us reduce from 200 to 400 milliseconds, which is great for these kind of UIs. Well, just imagine how long it would have took. Like, I got a TypeScript error, and it takes loading. Oh, bye-bye, I'm done. I'll be like that. So no one wants to do that. And if it's a medium MLP, it's going to reduce 500 to 800 milliseconds. And for large transformers, it's going to do much better. Cool. And we have some best practices over there, like we can lazy load the model. Like, that can significantly reduce the better the performance. Like, we all know, we all used to do lazy load stuffs. Yep. And we can memorize some expensive computations. We can memorize some, like the things that have been done by some web workers, some awesome things and all we can memorize, and we can use it better. And we can use, obviously, web workers. Web workers actually does magic. Like, it's kind of boon for us in this particular thing, ML computation. For those who don't know web workers is like, it doesn't disturb the main thread of JavaScript. It runs parallelly in a multi-thread so that our main UI won't be affected, but still, the job is getting done. Cool. And something that we all hate. But in this thing, this is works really good. We have to A/B test the ML features that we are building. So yeah, we need to get user feedback. We need to work on optimizing it. We need to work on bettering it. Because, how was ChatGPT when it was launched and how it is today? It's all because of that. And we can also consider adding ML-enhanced accessibility things. So accessibility is something that really helps in this particular thing. So yeah, every technology, everything comes up with a limitation. And similar to that, there are limitations for this as well. The first thing, cool. OK, before going that, I need some interactions from you. Where do you think this in-browser machine learning can be used better, where it can be leveraged? Any creativity? E-commerce. Yeah, we can do that. That's a good thing. Anything else? Translation. Yeah, translation, it works. Accessibility. Image processing. We can do a lot of stuff. I just classified my mood based on text some times ago. We can do that with help of camera. We can just see how the user is reacting and change the layout based on that. If they're like, oh, then we can change something. Yeah, that would work really amazing. So yeah, coming back to the limitations, we have heavy computations on weaker devices. This is a i7 machine, and it's working really good. Think the same thing running on a Pentium machine. We're not sure. It might still take some time to load the model. But applying some optimization technique will help us resolve this. Then the model size limit, as we talked about, we surely need optimization. There are lots of optimization techniques that we can apply. We can make it better. Yeah. The major issue over here, even when we talk about e-commerce, this data is not persistent. As we are not storing it anywhere in the server, it's just going to be for some times, how the user works, how the user reacts. We work the things, we show the feature, and we forget. It's not going to be persistent. So we have to do something about this. When the context is lost, everything's lost. It is use case sensitive. This is an important thing. If we use this for a right use case, for the perfect appropriate use case, as we did for our virtual try-on demo, it would create wonders. Impress the client. We literally impressed the client, and that went really well. Yeah, privacy and transparency. Sometimes AI is not great at privacy all the times. Sometimes it just shows its face. So we need to take care of that as well. OK, what all we saw just now? We have to start with clear use cases again, where we have to use it, where we can properly use it, where we can get the most out of this machine learning in browser. We have to choose the right approach, whether I'm going to use a pre-trained model like this, or I'm going to train a model myself. That's going to there. And again, optimization is there. Privacy. We need to take care of this. Yeah, accessibility. Someone spoke about accessibility. Good. We have to make sure it is accessible. And validate impact. Don't forget to do A/B test. I know it is boring, but still. Cool. When it is leveraged with a lot of things like edge computing, if we leverage the power of WASM and web GPUs and all, web GPUs and WASM and all, that would work really awesome. It can create wonders. Then we can create emotion-aware and adaptive UIs. It reads our face, it's going to switch the UI, it's going to theme based on a mood. This is going to be the future of React devs. Yeah, obviously it will be sometimes. Cool. I think it's done. This is not a UPI QR, so you can happily scan and follow me anywhere. And yeah, if you see me anywhere around beach, pool, somewhere, come say hi. I would like to connect with every one of you here. Just my name, Vishnudhasan. Thank you.
React India.